AI speaks. Let's review OpenAI guides. Let's begin with GPT models. OpenAI's GPT, generative pre-trained transformer models, have been trained to understand natural language and code. GPTs provide text output in response to their inputs. The inputs to GPTs are also referred to as prompts. Designing a prompt is essentially how you program a GPT model, usually by providing instructions or some examples of how to successfully complete a task. Using GPTs, you can build applications to draft documents, write computer code, answer questions about a knowledge base, analyze text, create conversational agents, give software a natural language interface, tutor in a range of subjects, translate languages, simulate characters for games, and much more. To use a GPT model via the OpenAI API, you will send a request containing the inputs and your API key and receive a response containing the model's output. Our latest models, GPT-4 and GPT 3.5 Turbo, are accessed through that chat completion API endpoint. Currently, only the older legacy models are available via the completions API endpoint. Model families, API endpoint. Take a look at the screen. You can experiment with GPTs in the playground. If you're not sure which model to use, then use GPT 3.5 Turbo or GPT-4. Chat completions API. Chat models take a list messages as input and return model-generated messages as output. Although the chat format is designed to make multi-turn conversations easy, it's just as useful for single-turn tasks without any conversation. An example API call looks as follows. Take a look at the screen. The main input in the messages parameter. Messages must be an array of message objects, where each object has a role, either system, user, or assistant. And content. Conversations can be as short as one message or many back and forth turns. Typically, a conversation is formatted with a system message first, followed by alternating user and assistant messages. The system message helps set the behavior of the assistant. For example, you can modify the personality of the assistant or provide specific instructions about how it should behave throughout the conversation. However, note that the system message is optional and the model's behavior without a system message is likely to be similar to using a generic message such as "you are a helpful assistant." User messages provide requests or comments for the assistant to respond to. Assistant messages store previous assistant responses, but can also be written by you to give examples of desired behavior. Including conversation history is important when user instructions refer to prior messages. In the example above, the user final question, where was it played? Only makes sense in the context of the prior messages about the World Series of 2020, because the models have a memory of past requests. All relevant information must be supplied as part of the conversation history in each request. If a conversation cannot fit within the model's token limit, it will need to be shortened in some way. Chat completions response format. An example chat completions API response looks as follows. Take a look at the screen. In Python, the assistant's reply can be extracted with response choice 0 message content. Every response will include a finish, reason. The possible values for finish, reason are stop, API return complete message, or a message terminated by one of the stop sequences provided via the stop parameter. Length, incomplete model output due to max tokens parameter or token limit. Function call, the model decided to call a function. Content filter, omitted content due to a flag from our content filters. Null, API response still in progress or incomplete. Depending on input parameters, like providing functions, as shown below, the model response may include different information. Function calling. In an API call, you can describe functions to GPT 3.5 Turbo 0613 and GPT 40613 and have the model intelligently choose to output a JSON object containing arguments to call those functions. The chat completion API does not call the function. Instead, the model generates JSON that you can use to call the function in your code. The latest models GPT 3.5 Turbo 0613 and GPT 40613 have been fine-tuned to both detect what a function should to be called depending on the input and to respond with JSON that adheres to the function signature. With this capability also comes potential risks. We strongly recommend building in user confirmation flows before taking actions that impact the world on behalf of users, sending an email, posting something online, making a purchase, etc. Under the hood, functions are injected into the system message in a syntax the model has been trained on. This means functions count against the model's context limit and are billed as input tokens. If running into context limits, we suggest limiting the number of functions or the length of documentation you provide for function parameters. Function calling allows you to more reliably get structured data back from the model. For example, you can create chatbots that answer questions by calling external APIs like ChatGPT plugins. Define functions like send email, string body string, or get current weather, location string, unit, Celsius, Fahrenheit. Convert natural language into API calls. For example, convert who are my top customers to get customer min ref int created before string limit int and call your internal API. Extract structured data from text. For example, define a function called exact data name string, birthday string, or SQL query string, and much more. The basic sequence of steps for function calling is as follows. Call the model with the user query and a set of function defined in the function's parameter. The model can choose to call a function. If so, the content will be stringified JSON object adhering to your customer schema node. 2. The model may generate invalid JSON or hallucinate parameters. Parse the string into JSON in your code and call your function with the provided arguments if they exist. Call the model again by appending the function response as a new message and let the model summarize the results back to the user. You can see these steps in action through the example below. Hallucinated outputs in function calls can often be mitigated with the system message. For example, if you find that a model is generating function calls with functions that weren't provided to it, try using a system message that says only use the functions you have been provided with. In the example above, we send the function response back to the model and let it decide the next step. It responded with a user-facing message, which was telling the user the temperature in Boston, but depending on the query, it may choose to call a function again. For example, if you ask the model, find the weather in Boston this weekend, book dinner for 2 on Saturday, and update my calendar, and provide the corresponding functions for these queries, it may choose to call them back to back and only at the end create a user-facing message. If you want to force the model to call a specific function, you can do so by setting function call name, insert function name. You can also force the model to generate a user-facing message by setting function call none. Note that the default behavior function call auto is for the model to decide on its own whether to call a function and, if so, which function to call. You can find more examples of function calling in the OpenAI cookbook. Completions API. The Completions API endpoint received its final update in July 2023 and has a different interface than the new Chat Completions endpoint. Instead of the input being a list of messages, the input is a freedom text string called a prompt. An example API call book as follows. Token log probabilities. The Completions API can provide a limited number of log probabilities associated with the most likely tokens for each output token. This feature is controlled by using the log probs field. This can be useful in some cases to assess the confidence of the model in its output. Inserting text. The Completions endpoint also supports inserting text by providing a suffix in addition to the standard prompt, which is treated as a prefix. This need naturally arises when writing long-form text, transitioning between paragraphs following an outline or guiding the model toward an ending. This also works in code and can be used to insert in the middle of a function or file. Completions response format. An example Completions API response looks as follows. In Python, the output can be extracted with response choices 0 text. The response format is similar to the response format of the Chat Completions API, but also includes the optional field log props. Chat completions versus completions. The chat completions format can be made similar to the completions format by constructing a request using a single user message. For example, one can translate from English to French with the following completions prompt. Translate the following English text to French text. And an equivalent chat prompt would be Take a look at the screen. Likewise, the completions API can be used to simulate a chat between a user and an assistant by formatting the input accordingly. The difference between these APIs derives mainly from the underlying GPT models that are available in each. The Chat Completions API is the interface to our most capable model, GPT-4, and our most cost-effective model, GPT 3.5 Turbo. Reference GPT 3.5 Turbo performs at a similar capability level to Text DaVinci 003, but at 10% the price per token. See price in details. Which model should I use? We generally recommend that you use either GPT-4 or GPT 3.5 Turbo. Which of these you should use depends on the complexity of the tasks you're using. The Model 4 GPT-4 generally performs better on a wide range of evaluations. In particular, GPT-4 is more capable of carefully following complex instructions. By contrast, GPT 3.5 Turbo is more likely to follow just one part of a complex multi-part instruction. GPT-4 is less likely than GPT 3.5 Turbo to make up information, a behavior known as hallucination. GPT-4 also has a large context window with a maximum size of 8,192 tokens compared to 4,096 tokens for GPT 3.5 Turbo. However, GPT 3.5 Turbo returns outputs with lower latency and costs much less per token. We recommend experimenting in the playground to investigate which models provide the best price-performance trade-off for your usage. A common design pattern is to use several distinct query types, which are each dispatched to the model appropriate to handle them. GPT best practices. An awareness of the best practices for working with GPTs can make a significant difference in application performance. The failure models that GPTs exhibit and the ways of working around or correcting those failure models are not always intuitive. There is a skill to working with GPTs, which has come to be known as prompt engineering. But as the field has progressed, its scope has outgrown merely engineering the prompt into engineering systems that use model queries as components. To learn more, read our guide on GPT practices, which covers methods to improve model reasoning, reduce the likelihood of model hallucinations, and more. You can also find many useful resources, including code samples, in the OpenAI cookbook. Managing tokens. Language models read and write text in chunks called tokens. In English, a token can be as short as one character or as long as one word. And in some languages, tokens can be even shorter than one character or even longer than one word. The total number of tokens in an API call effect. How much your API calls cost as you pay per token. How long your API call takes, as writing more tokens takes more time. Whether your API call works at all, as total token must be below the model's maximum limit, 4,096 tokens for GPT 3.5 Turbo. Both input and output tokens count toward these quantities. For example, if your API call used 10 tokens in the message input and you received 20 tokens in the message output, you would be billed for 30 tokens. Note, however, that for some models, the price per token is different for tokens in the input versus the output. See the pricing page for more information. To see how many tokens are used by an API call, check the usage field in the API response. Response usage, total tokens. Chat models like GPT-3 Turbo and GPT-4 use tokens in the same way as the models available in the completion API. But because of their message-based formatting, it's more difficult to count how many tokens will be used by a conversation. To see how many tokens are in a text string without making an API call, use OpenAI token Python library. Example code can be found in the OpenAI Cookbook's guide on how to count tokens with tick token. Each message passed to the API consumes the number of tokens in the content role and other fields, plus a few extra for behind-the-scenes formatting. This may change slightly in the future. If a conversation has too many tokens to fit within a model's maximum limit, for example, more than 4,096 tokens for a GPT 3.5 Turbo, you will have to truncate, omit, or otherwise shrink your text until it fits. Beware that if a message is removed from the message input, the model will lose all knowledge of it. Note that very long conversations are more likely to receive incomplete replies. For example, a GPT 3.5 Turbo conversation that is 4,090 tokens long will have its reply cut off after just 6 tokens. FAQ. Why are model outputs inconsistent? The API is non-deterministic by default. This means that you might get a slightly different completion every time you call it, even if your prompt stays the same. Setting temperature to 0 will make the outputs mostly deterministic, but a small amount of variability will remain. How should I set the temperature parameter? Lower values for temperature results in more consistent outputs, while higher values generate more diverse and creative results. Select the temperature value based on the desired trade-off between coherence and creativity for your specific application. Is fine-tuning available for the latest models? No. Currently, you can only fine-tune base GPT-3 models, DaVinci, Curie, Babbage, and Ada. See the fine-tuning guide for more details on how to use fine-tuned models. Do you store the data that is passed into the API? As of March 1st, 2023, we retained your API data for 30 days, but no longer use the data sent via the API to improve our models. Learn more in our data usage policy. Some endpoint offer 0 retention. How can I make my application more safe? If you want to add a moderation layer to the outputs of the chat API, you can follow our moderation guide to prevent content that violates OpenAI's usage policies from being shown. Should I use ChatGPT or the API? ChatGPT offers chat interface to the models in the OpenAI API and a range of built-in features such as integrated browsing, code execution, plugins, and more. By contrast, using OpenAI's API provides more flexibility. GPT best practices. This guide shares strategies and tactics for getting better results from GPTs. This guide shares strategies and tactics for getting better results from GPTs. The methods described here can sometimes be deployed in combination for greater effect. We encourage experimentation to find the methods that work best for you. Some of the examples demonstrated here currently work only with our most capable model, GPT-4. If you don't yet have access to GPT-4, consider joining the waitlist. In general, if you find that a GPT model fails at a task and a more capable model is available, it's often worth trying again with a more capable model. 6 strategies for getting better results. Write clear instructions. GPTs can't read your mind. If outputs are too long, ask for brief replies. If outputs are too simple, ask for expert-level writing. If you dislike the format, demonstrate the format you'd like to see. The less GPTs have to guess at what you want, the more likely you'll get it. Tactics. Include details in your query to get more relevant answers. Ask the model to adopt a persona. Use delimiters to clearly indicate distinct parts of the input. Specify the steps required to complete a task. Provide examples. Specify the desired length of the output. Provide reference text. GPTs can confidently invent fake answers, especially when asked about esoteric topics or for citations and URLs. In the same way that a sheet of notes can help a student do better on a test, providing reference tests to GPTs can help in answering with fewer fabrications. Tactics. Instruct the model to answer using a reference text. Instruct the model to answer with citations from reference text. Split complex tasks into simpler subtasks. Split complex tasks into simpler subtasks. Just as it is good practice in software engineering to decompose a complex system into a set of modular components, the same is true of tasks submitted to GPTs. Complex tasks tend to have higher error rates than simpler tasks. Furthermore, complex tasks can often be redefined as a workflow of simpler tasks, in which the outputs of earlier tasks are used to construct the inputs to later tasks. Tactics. Use intent clarifications to identify the most relevant instructions for a user query. For dialogue applications that require very long conversations, summarize or filter previous dialogue. Summarize long documents piecewise and construct a full summary recursively. Give GPTs time to think. If asked to multiply 17 by 28, you might not know it instantly, but can still work it out with time. Similarly, GPTs make more reasoning errors when trying to answer right away, rather than taking time to work out an answer. Asking for a chain of reasoning before an answer can help GPTs reason their way toward correct answers more reliably. Tactics. Instruct the model to work out its own solution before rushing to a conclusion. Use inner monologue or a sequence of sequences. Use inner monologue or a sequence of queries to hide the model's reasoning process. Ask the model if it missed anything on previous passes. Use external tools. Compensate for the weakness of GPTs by feeding them the outputs of other tools. For example, a text retrieval system can tell GPTs about relevant documents. A code execution engine can help GPTs do math and run code. If a task can be done more reliably or efficiently by a tool rather than by a GPT, offload it to get the best of both. Tactics. Use embeddings-based search to implement efficient knowledge retrieval. Use code execution to perform more accurate calculations or call external APIs. Give the model access to specific functions. Test changes systematically. Improving performance is easier if you can measure it. In some cases, a modification to a prompt will achieve better performance on a few isolated examples, but lead to worse overall performance on a more representative set of examples. Therefore, to be sure that a change is net positive to performance, it may be necessary to define a comprehensive test suite, also known as an EVIL. Tactic: evaluate model outputs with reference to gold standard answers. Tactics: each of the strategies listed above can be instantiated with specific tactics. These tactics are meant to provide ideas for things to try. They are, by no means, fully comprehensive, and you should feel free to try creative ideas, not represented here. Strategy: write clear instructions. Tactic: include details in your query to get more relevant answers. In order to get a highly relevant response, make sure that requests provide any important details or context. Otherwise, you are leaving it up to the model to guess what you mean. Worse: how to add numbers in Excel. Better: how to add up a row of dollar amount in Excel. I want to do this automatically for a whole sheet or rows with all totals ending up on the right in a column called total. Who is president? Who was the president of Mexico in 2021, and how frequently are elections held? Write code to calculate the Fibonacci sequence. Write a TypeScript function to efficiently calculate the Fibonacci sequence. Comment the code liberally to explain what each piece does and why it's written that way. Summarize the meeting notes. Summarize the meeting notes in a single paragraph. Then write a markdown list of the speakers and each of their key points. Finally, list the next steps or action items suggested by the speakers, if any. Tactic: ask the model to adopt a persona. The system message can be used to specify the persona used by the model in its replies. When I ask for help to write something, you will reply with a document that contains at least one joke or playful comment in every paragraph. Write a thank you note to my steel bolt vendor for getting the delivery in on time and in short notice. This made it possible for us to deliver an important order. Tactic: use delimiters to clearly indicate distinct parts of the input. Delimiters like triple quotation marks, XML tags, section titles, etc. can help demarcate sections of text to be treated differently. Summarize the text delimited by triple quotes with a haiku. Insert text here. System: you will be provided with a pair of articles delimited with XML tags about the same topic. Please first summarize the arguments of each article, then indicate which of them makes a better argument and explain why. Insert first article here. Insert second article here. System: you will be provided with a thesis abstract and suggest a title for it. The thesis title should give the reader a good idea of the topic of the thesis, but should also be eye-catching. If the title does not meet these criteria, suggest 5 alternatives. User, abstract, insert abstract here, title, insert title here. For straightforward tasks such as these, using delimiters might not make a difference in the output quality. However, the more complex the task is, the more important it is to disambiguate task details. Don't make GPTs work to understand exactly what you're asking of them. Tactic: specify the steps required to complete a task. Some tasks are better specified as a sequence of steps Writing the steps out explicitly can make it easier for the model to follow them. System. Use the following step-by-step instructions to respond to user inputs. Step 1. The user will provide you with text in triple quotes. Summarize this text in one sentence with a prefix that says summary. Step 2. Translate the summary from step 1 into Spanish with a prefix that says translation. Tactic. Provide examples. Providing general instructions that apply to all examples is generally more efficient than demonstrating all permutations of a task by example. But in some cases, providing examples may be easier. For example, if you intend for the model to copy a particular style of respondents to user queries, which is difficult to describe explicitly, this is known as few-shot prompting. System. Answer in a consistent style. User. Teach me about patience. Assistant. The river carves the deepest valley, flows from a modest spring. The grandest symphony originates from a single note. The most intricate tapestry begins with a solitary thread. The most intricate tapestry begins with a solitary thread. Teach me about the ocean. User. Teach me about the ocean. Tactic. Specify the desired length of the output. You can ask the model to produce outputs that are of a given target length. The targeted output length can be specified in terms of the count of words, sentences, paragraphs, bullet points, etc. Note, however, that instructing the model to generate a specific number of words does not work with high precision. The model can more reliably generate outputs with a specific number of paragraphs or bullet points. User. Summarize the text delimited by triple quotes in about 50 words. Insert text here. Summarize the text delimited by triple quotes in 2 paragraphs. Insert text here. Summarize the text delimited by triple quotes in 3 bullet points. Insert text here. Strategy. Provide reference text. Tactic. Instruct the model to answer using reference text. If we can provide a model with trusted information that is relevant to the current query, then we can instruct the model to use the provided information to compose its answer. System. Use the provided articles delimited by triple quotes to answer questions. If the answer cannot be found in this article, write, I could not find an answer. User. Insert articles each delimited by triple quotes. Question. Insert question here. Given that ChatGPTs have limited context windows, in order to apply this tactic, we need some way to dynamically look up information that is relevant to the question being asked. Embedding can be used to implement efficient knowledge retrieval. See the tactic. Use embeddings-based search to implement efficient knowledge retrieval. For more details on how to implement this tactic, instruct the model to answer with citations from reference text. If the input has been supplemented with relevant knowledge, it is straightforward to request that the model add citations to its answers by referencing passages from provided documents. Note that citations in the output can then be verified programmatically by string matching within the provided document. System. You will be provided with a document delimited by triple quotes and a question. Your task is to answer the question using only the provided document and to cite the passages of the document used to answer the question. If the document does not contain the information needed to answer this question, then simply write insufficient information. If an answer to the question is provided, it must be annotated with a citation. Use the following format to cite relevant passages. User. Insert document here. Question. Insert question here. Strategy: split complex tasks into simpler subtasks. Tactic: use intent classification to identify the most relevant instructions for a user query. For tasks in which lots of independent sets of instructions are needed to handle different cases, it can be beneficial to first classify the type of query and to use that classification to determine which instructions are needed. This can be achieved by defining fixed categories and hard-coding instructions that are relevant for handling tasks in a given category. This process can also be applied recursively to decompose a task into a sequence of stages. The advantage of this approach is that each query will contain only those instructions that are required to perform the next stage of a task, which can result in lower error rates compared to using a single query to perform the whole task. This can also result in lower costs since large prompts cost more to run. Suppose, for example, that for a customer service application, queries could be usefully classified as follows. System: you will be provided with customer service queries. Classify each query into a primary category and a secondary category. Provide your output in JSON format with the keys primary and secondary. Primary categories: billing, technical support, account management, or general inquiry. Billing secondary categories: unsubscribe or update, add a payment method, explanation for charge, dispute a charge. Technical support secondary categories: troubleshooting, device compatibility, software updates. Account management secondary categories: password reset, update personal information, close account, account security. General inquiry secondary categories: product information, pricing, feedback, speak to a human. User: I need to get my internet working again. Based on the classification of the customer query, a set of more specific instructions can be provided to a GPT model to handle next steps. For example, suppose the customer requires help with troubleshooting. System: you will be provided with customer service inquiries that require troubleshooting in technical support context. Help the user by ask them to check that all cables to from the router are connected. Note that it is common for cables to come loose over time. If all cables are connected and the issues persist, ask them which router model they are using. Now you will advise them how to restart their device. If the model number MTD327GA, advise them to push the red button and hold it for 5 seconds, then wait for 5 minutes before testing the connection. If the model number is MTD327S, advise them to unplug and re-plug it, then wait 5 minutes before testing the connection. If the customer's issue persists after resisting the device and waiting 5 minutes, connect them to IT support by outputting IT support requested. If the user starts asking questions that are unrelated to the topic, then confirm if they would like to end the current chat about troubleshooting and classify their request according to the following schema. Insert primary/secondary classification scheme from above here. I need to get my internet working again. Notice that the model has been instructed to emit special strings to indicate when the state of the conversation changes. This enables us to turn our system into a state machine, where the state determines which instructions are injected. By keeping track of state, what instructions are relevant at that state, and also optionally what state transitions are allowed from that state. We can put guardrails around the user experience that would be hard to achieve with a less structured approach. Tactic: for dialogue applications that require very long conversations, summarize or filter previous dialogue. These GPTs have a fixed context length dialogue between a user and an assistant in which an entire conversation is included, and the context window cannot continue indefinitely. There are various workarounds to this problem, one of which is to summarize previous turns in the conversation. Once the size of the input reaches a predetermined threshold length, this could trigger a query that summarizes part of the conversation, and the summary of the prior conversation could be included as part of the system message. Alternatively, a prior conversation could be summarized asynchronously in the background through the entire conversation. An alternative solution is to dynamically select previous parts of the conversation that are most relevant to the current query. See the tactic: use embedding-based search to implement efficient knowledge retrieval. Tactic: summarize long documents piecewise and construct a full summary recursively. Since GPTs have a fixed context length, they cannot be used to summarize a text longer than the context length minus the length of the generated summary in a single query. Summarize a very long document such as a book, we can use a sequence of queries to summarize each section of the document. Section summaries can be concatenated and summarized, producing summaries of summaries. This process can proceed recursively until an entire document is summarized. If it's necessary to use information about earlier sections in order to make sense of later sections, then a further trick that can be useful is to include a running summary of the text that precedes any given point in the book while summarizing context at that point. The effectiveness of this procedure for summarizing books can be studied in previous research by OpenAI using variants of GPT-3. Strategy: give GPTs time to think. Tactic: instruct the model to work out its own solution before rushing to conclusion. Sometimes we get better results when we explicitly instruct the model to reason from first principles before coming to a conclusion. Suppose, for example, we want the model to evaluate a student's solution to do a math problem. The most obvious way to approach this is to simply ask the model if the student's solution is correct or not. System: determine if student's solution is correct or not. Problem statement: I'm building solar power installation and I need help working out the financials. Land cost $100 divided by square foot. I can buy solar panels for $250 divided by square foot. I negotiate a contract for maintenance that will cost me a flat $100,000 per year and an additional $10 per square foot. What is the total cost for the first year of operations as a function of the number of square feet? Student's loan, colon. Let X be the size of the installation in square feet. 1. Land cost, 100x. 2. Solar panel cost, 250x. 3. Maintenance cost, 100,000 plus 100x. Total cost, colon. 100x plus 250x plus 100,000 plus 100x equals 450x plus 100,000. The student's solution is correct. But the student's solution is actually not correct. We can get the model to successfully notice this by prompting the model to generate its own solution first. System: first work out your own solution to the problem. Then, compare your solution to the student's solution and evaluate if the student's solution is correct or not. Don't decide if the student's solution is correct until you have done the problem yourself. User, problem statement. I'm building solar power installation and I need help working out the financials. Land cost $100 per square foot. I can buy solar panels for $250 per square foot. I negotiated a contract for maintenance that will cost me a flat $100,000 per year and an additional $10 per square foot. What is the total cost for the first year of operations as a function of the number of square feet? Student solution: let X be the size of the installation in square feet. Land cost 100x, solar panel cost 250x, maintenance cost 100,000 plus 100x, total cost 100x plus 250x plus 100,000 plus 100x equals 450x plus 100,000. Assistant: let X be the size of the installation in square feet. Land cost 100x, solar panel cost 250x, maintenance cost 100,000 plus 10x, total cost 100x plus 250x plus 100,000 plus 10x equals 360x plus 100,000. The student solution is incorrect. They made an error in the maintenance cost calculation using 100x instead of 10x. The correct total cost for the first year of operations is 360x plus 100,000. Tactic: use inner monologue or a sequence of queries to hide the model's reasoning process. The previous tactic demonstrates that it is sometimes important for the model to reason in detail about a problem before answering a specific question. For some applications, the reasoning process that a module uses to arrive at a financial answer would be appropriate to share with the user. For example, in tutoring applications, we may want to encourage students to work out their own answers, but a model's reasoning process about the student's solution could reveal the answer to the student. Inner monologue is a tactic that can be used to mitigate this. The idea of inner monologue is to instruct the model to put parts of the output that are meant to be hidden from the user into a structured format that makes parsing them easy. And before presenting the output to the user, the output is parsed and only part of the output is made visible. System: follow the steps to answer correct. User: strategy: use external tools. Tactic: use embedding-based search to implement efficient knowledge retrieval. Tactic: use code execution to perform more accurate calculations or call external APIs. Warning: executing code produced by a model is not inherently safe, and precautions should be taken in any application that seeks to do it. In particular, sandbox code execution environment is needed to limit the harm that untrusted code could cause. Tactic: give the model access to specific functions. Strategy: test changes systematically. Tactic: evaluate model outputs with reference to gold standard answers. That's it. I hope my monologue helped you better understand OpenAI guides. I will be back soon. AI speaks. AI speaks.